Hello again. In this video, I show you how to create linear models. So previously we had seen how to figure out how much relationship two variables have in a data set. But now we will now create the equations of the models. The linear models we're talking about, many times you will see them also being referred to as creating the line of best fit. So if you see questions that say create a line of best fit, that's the same thing as saying you are creating a linear model. Previously, I showed you a few examples where the data to see the kind of correlations that there may be. Like this one here, where we're looking at the number of hours of study and grade on an exam. We said that's probably positively correlated based on the information we have on this scatter plot. And then I also showed you an example of the number of sick days taken and the age of the employees, and we saw that those have a negative correlation. Now the lines of best fit might look like this for the first one, right? It's the line that most represents the point. It doesn't mean that the line has to go through all the point. And the method that is used to create this is called the least squares method. We won't discuss that here. Similarly, for the second line, the line of best fit might look like this. Okay, and you can see that that line is falling. Okay, so what we want to do is to create the equation of these lines of best fit. That's what I will show you to do next. From your previous math studies, you will remember that the equation of a straight line looks like so: y equals to mx plus b, where m represents the slope of the line. The slope of the line is rise divided by run, which means, you know, how high do you go for every unit increment on the x-axis. And similarly, for b is just the y-intercept. So that's the point where the line goes through the y-axis. Okay, that's what the y-intercept represents. For our specific purpose, in your text, they represent the equation of the linear model as shown. Y hat equals to b sub 0 plus b sub 1 times x. The y-intercept is b sub 0, that's just a y hat intercept, and b sub 1 is the slope of the line. Now you can also write it in the other way too. You can write as y hat equals to b1x plus b sub 0. Okay, those are the same things. So your b sub 1, there's a formula for that. Here's the formula we're going to use for b sub 1. Okay, and for b sub 0, our formula is as shown as well. B sub 0 is y bar minus b sub 1 times x bar, which is just the same thing as summation of y over n minus b1 summation of x over n. So we will use this to create linear models. So for example, we've seen this example before, the one where we calculated R, the correlation coefficient, that the one I did with you in the previous video. But this time we are going to develop a linear regression model for that same data set, years of schooling versus income. And after we have created a linear model, we are going to use that model to predict the annual income for a person with 18 years of schooling. So that means that this person probably went to grad school. Maybe they have a master's degree or something like that. Okay. So what do we need? Well, for our formula for B1, we need all this information from this table. The only column we don't need here is the y squared column. So if you are creating this from scratch, you don't need to create y squared, but you create everything else. So if we take all that information, all those sums, and we substitute in our formula, we will have as shown, right? Summation of xy is 2,585 and so on, which if you compute using your calculator, you will obtain 3.02. That is B1. And for B sub 0, our formula is shown like we had before. Excuse me. And then we will just substitute the information from the table in there, and our result will be 5.30. Therefore, our linear model is y hat equals to 5.30 plus 3.02 times x. That is the equation of the best line of fit for this data set. Now, here's our model that we just created. Y-intercept is 5.30 and the slope is 3.02. Now, these are in thousands, you remember. So that means that the slope of the line, how high does it go for every unit increment on the x-axis. So that means that for every year of schooling on the x-axis, how many thousands of dollars more do you get? So according to this model, you get $3,020 increment for every extra year of schooling. That's what this means, starting from 5.30. Now, what does that look like? Where we had our scatter plot previously, but the line itself, the y-intercept is this point, this green point right here, 5.3. So that's $5,300, okay, for a person with zero education. That's what that means. And then for every year of schooling, you get 3.02 thousand, something like that, which is $3,020. So that line will look like this. Okay, that is what that linear model would look like. And then we said we're going to use this to predict the annual income for a person who went to grad school. Okay, he has 18 years of education. So that means in our model, we will let x be 18. So if x is 18 years, y hat will be 5.3 plus 3.02 times 18. That will just give us 559.66. So which translates to $59,660. So now you try. For the same example you looked at before, and now you develop a linear regression model for it, and then use your regression model to predict the grade for a student who studied for 8 hours. Like we did in that previous video, please pause the video now while you try the example, and when you have finished, you may continue the video to see what I have done. So go ahead and pause the video right now. Okay, so what did you do? Well, first of all, we said we need this chart here. We need all that summation of x squared, summation of y squared, summation of xy. We don't need summation of x squared here. Okay, you can take that out. You don't need to do that one if you are creating this from scratch, but I just copied it because we did it before. And our linear model is as shown. Okay, so if you take your B1 and you substitute all the information there, your result should be 5.86 or something very close to that. I hope that's what you obtained. And for B sub 0, your result there should be 52.32. So therefore, our linear model is as shown. Y hat is 52.32 plus 5.86 multiplied by x. To use this now to figure out the grade for a student who studied for 8 hours, so we want to predict that, we will use our linear model and let x be 8. So if x is 8, y hat will be 99.20. So that means that student should do really well if they worked hard. So that brings us to the end of our videos on linear regression.